ratios and proportions. We didn't talk about just a second ago about the physical shape of everything. So when two shapes are in proportions, that means they're going to be the same shape but a different size. So when we're talking about physical objects, just know that proportion means same shape and different size. So you can have two shapes, like two rectangles, being proportioned because they're the same shape. So to figure that out, we just see, well, this side is 3, this side is 33. 11 times bigger, right? So if this side is 5, then this side also has to be 11 times bigger. So this side would have to be 55. Right? So that's the physicality of proportions. Just means be consistent. On the notes, we are doing top and bottom of the ratios. You have to multiply or divide by the same. But if we're talking about physical objects, it just means the different sides will have to line up and be the same growth or what do you call that? Dilation, when it grows or shrinks at the same. Okay. So go ahead and look at 6. Like you can look at 6. Like this one is 8. This one is 40. So the 40 is how much bigger? 5 times bigger, right? So you have to 5 times bigger. So the other sides are all going to be the same. So if this is 9, and you go 5 times bigger, how big is this? 45. Yeah. Not too bad, right? X equals 45. Go ahead and do 7 and 8, just to finish that up real fast. We are using some easy numbers still, and then later on we're going to get into, okay, decimals and things like that, but I really want to get the sense of this first. If you think you're comfortable with anything else on the front side, you can go ahead and do that as well. I'll go over it, but if you're comfortable with it, go ahead on your own. If we want to work backwards and say, well, are these two the same shape? We can just take the numbers of the first shape, 3 and 5, so I did 3 over 5, and ask myself, is it the same as these numbers, 33 over 55? And if you're able to figure out, like, oh yeah, we multiply by 11 top and bottom, then and it's the same number on the top and bottom, then they're going to be proportional. We could also multiply the diagonals, like kind of use that heart, and say, well, it's 5 times 33 equals 3 times 55. And those will be the same number, so the answer would be yes. So you know they're the same shape. And that's really what number 1 through 4 is all about. Let's say if we had two shapes, right? We want to see if they're actually the same shape in proportion to one another or not. So we could say, like, oh yeah, 3 times 2. That gives me 6. And then, well, see if it's the same number that works on the bottom. So 4 times 2 equal this. And if it does, then the answer is yes, they're proportional. So if we actually drew rectangles or some shape using those dimensions, they would appear to be the same shape. And of course, if we went over here, 3 times what is 18? Right, you get 6. So does that work here? 4 times 6, does that equal 16? No. So the answer here would be no. Right? The 6 number on top that works is 6, but the number on bottom that works is actually 4. So they're not proportional if these two numbers are not the same. It has to grow the same on all sides. Can't grow at different sizes. Another way of looking at that would be to say, well, this 3 over 4, if we multiply these two cross products together, so 3 times 16, okay, is that equal to 8 times 4? 18 times 4. And yeah, we get 48 on the left, and we get 72 on the right. So no, that's another way to get an answer of no, because the cross products are not the same. So a couple ways of looking at that. All right, lastly, on front are some more realistic problems. So we have like 10 nectarines that cost $8. 5 for $4. So how many nectarines, I'll call it N for nectarines, how many nectarines can you get for $4? And you can figure that out either using the cross products, but on these ones they're already simplified pretty easily for you. So you can figure out, well, $4 is half of $8. So if I can get 10 of them for 8, I can probably get 5 nectarines for $4. Now, one thing about word problems, and this is the thing, by the way, this is important, you need to write out units. For whatever your answer is for a word problem, in general, always have units. Whether it's dollars, or how many of something you bought, or how many miles you drove, or something like that, you never just put a number for a word problem as your answer. You need to be very clear of what it is you're doing. Now, about 10 years ago, they sent NASA, when we still had the space program, we sent a probe out towards Mars. This thing cost close to $1 billion, and it missed it. It missed Mars. Missed Mars. Because is a multinational team that made this satellite, and some of them were using yards, and some were using kilometers, and some were using miles. They didn't write their units down of what they were working on, so they mixed them up, and then when they sent this $1 billion piece of metal toward the planet that's actually pretty big, it missed and just went into space, and they waved by. So it's actually pretty important that we put our units on our answers. It's not something like math teachers just like that. It's a good thing to do so we don't have mix-ups of that kind of magnitude ever again. All right, so I'll let you work on those for a second. Try to finish up the front, working with each other. Okay, make sure you did indeed follow the directions that you have set up and you solve the proportion. Now, remember what I said in the beginning, that we're practicing on easy problems so that when we get to the back, you know how to do them on more difficult problems. But if you skip the part where you actually write a proportion, that's why the hard problems get almost too difficult to solve, is because you're skipping it on the easy parts. So even though it seems easy, never take it upon yourself to say, well, I don't need to do that, I'm doing less, because I don't need that. It's definitely for a reason and for a purpose. We're never going to give you something to do just because that's what we told you to do. Always going to be a reason. So now, if we flip over to the back, you can see that it's not quite the same. That looking at this, I go, what do you have to multiply 7 by to get to 6? Or divide, and you can't do adding and subtracting. It has to be multiplying and dividing. Because I remember the shapes get 5 times big, 5 times small. So it has to be times multiplication. So all of a sudden, that maybe fast method that we could do here and just say, oh, if 4 is half of 8, so half of 10 is 5, doesn't really work anymore. And that's why I had that other method I showed you about having fractions when they're in proportion, that their cross products are also equal to one another. So we could take these and say, all right, 10 times 6, since I know these are equal to each other, is going to be equal to 7 times some number. 7 times A. And if we just solve this, we'll have what A equals. So in this case, it's going to be 60, 10 times 6, equals 7 times what? Now, I saw this on the quiz a little bit, that some people got to this point, and they said, well, you can't multiply 7 by any number, you get 60, it doesn't go in easily. And then they write no solution. It's okay to have decimal and fraction answers. So if you get to this point, you have to just keep going. You don't stop and say it can't be done. It's kind of like saying that if you went to go buy something, change is not allowed to exist. Everything has to be a perfect dollar, and there's no such thing as change. It's like, yeah, there's going to be change involved. Okay, it's okay if there's a fraction or decimal. Don't stop and say it's impossible. You just have to do the change. So when we do this, 60 divided by 7, that's our answer. A is it's what's left. So our answer is 60 over 7. But let's read the directions just to make sure. So write the answer as a reduced fraction. Did we reduce the fractions? It's fully reduced, 60 over 7. Right? If you're not sure, you can try to divide 7 into the top, or you can put it in the calculator, but you want to make sure you write it as a reduced fraction. So in this case, this is fully reduced, so this is your answer. You notice how on the front it was always this nice whole number, but that's not always going to be the case. Okay? It's not always the case, and that's okay. Okay? Don't get freaked out. Don't stop and say, well, you can't do it because it's not perfect. It's okay. Okay? So let's work on this method. Let's go over actually to 16. See, on 16, once again, you can't multiply or divide something and go from 9 to 7 or 7 to 9. You kind of have to do this method. So 9 times what? This diagonal is going to be equal to 7 times what? I mean 7 times 5, not what. So yeah. Now you can estimate. You know that 9 times, what is it? 4 is 36. So you can kind of estimate this number is going to be something a little less than 4 because it equals 35. You know, so it's going to be somewhere a little bit less than 4. So if you go down here and divide both sides by 9, get 35 over 9. That could be your final answer. Now, what if it asks for a decimal? You could just plug it in the calculator and find out that this is 3.9. It's about 3.9 if you round it. So it works. All right. So let's work on a few of those. Why don't you go down and do 17, 18. Check with someone next to you and see how that goes. Just by multiplying like this, not using a shortcut. Okay? Lastly, let's take a look at these. As you can see, things got even a little more complicated now. And if you try doing like 2 times what equals x minus 2 or 4 times what equals 6, if you're still trying to do that method, which I saw a few who were, this is where all that breaks down and stops working. So that was the reason behind me showing you using the diagonals instead, because that will always work regardless of anything. So this is the method you want to use from this point out. If you're not doing this, if your work does not look like this, this is where you definitely want to transition to doing this method. I mean, yeah, there's faster ways of doing problems when the numbers are nice, like the nectarines, but in reality, it's not always going to be that way. You got to be able to handle fractions, answers, decimals, and everything else as well, not just the easy stuff. Okay. So, unless you are told otherwise, you should probably just keep on trying to use the same method and see if it works. So here's a good way if you're like thinking, should I keep going on? Should I try it out? Here's a good process to go through. Right? I'm just going to keep doing the same thing. So I'm going to multiply 6 times 2, right? On one side. And my other diagonal is going to be 4 times x minus 2. And multiply them together. Now, does that look good? Is that the same thing we've always done? Yeah. Right. So let's go through solid as is and see what happens. So left side is 2 times 6. And minus 2. I can solve this by trying to get x by itself. So I've got a minus 2 I want to add to both sides. So, no, just do the normal stuff. And 12 plus 2 is 14. Bring down my 4 times unknown number. And we're trying to find 4 times 1 is 14. So 5 both sides by 4. We get 7 over 2. We reduce it all the way. Okay. Or 3.5, right? 7 over 2, 3.5, something like that. You can get a decimal for anything, yes. Very, yeah, anything. So, but now, if you're just taking a guess, let's say you didn't know how to do this, and you're just like, well, I'm going to try it out, see what happens if I just do it this way. You want to check your answer. And I saw this on the quiz, as I mentioned before, if you checked your answer, you probably knew if it was right or wrong and then fixed it if it was wrong. If you didn't check your answer, you might have got an answer like this that said, oh, this thing looks really good. I did all the steps and everything there, but you didn't check it and then you end up getting it wrong. So there's some little detail, usually negative, but there's some detail missing. So just for kicks, let's go ahead and check it to see if it's right. Not just say I wrote something so I'm done, but actually care about if it's right or not. There's no secret here. You can know if your answer is right if you want to. If you just have to want. Okay? So instead of, just to make it easy, instead of doing 7 over 2, I'm going to use 3.5 in my check. That's just a little easier on the calculator. So 3.5 is the same as 7 over 2 minus 2, all divided by 6. And we just have to see if the left side equals the right side. So on your calculator, you can punch in 2 divided by 4, and you should get 0.5. Right, half. And then what happens if you punch this in? What's 3.5 minus 2? That's 1.5. And what's 1.5 divided by 6? Calculator, punch in. That's it. 1.5. 1.5 divided by 6, see what you get. What do you get? Point what? 0.25. Now, so what is the conclusion from this? What's the conclusion? This is important. This is probably the most important part of the whole day. Right here. What is the conclusion to be reached that this side is 0.5 and this side is 0.25? We just did a check. What does that mean? Not no solution. It means our answer is wrong. Yeah, we just did a check. We took our answer and we plugged it in. We did not get the same thing on both sides. Our answer is wrong. Okay? That's what that means.
Did you just do that on purpose?
Mm-hmm.
I knew it.
Yeah. So I did this on purpose. I did this on purpose because I was very careful at the beginning and saying, does this look good? And everybody's like, uh-huh. Yeah, it looks great. We solved it. We did everything. Got an answer. But so many of you stopped here on the quiz and said, that looks great. I'm done. And then you didn't do this last step to find out, look, I didn't get the same answer. My answer is wrong. It looks great, but it's wrong. So you don't want to just go off of, I did it, so I'm done. You've got to check it. So this is where you go back afterwards and you find out, okay, now that I know something is wrong. Now that we know something's wrong, we go back and we figure it out. Now what you don't want to do is erase everything and start over because it could be 99% correct, right? And you just need to fix the negative. Now all of a sudden the whole thing is right because of one little thing. So it's not starting over. It's finding the mistake and just correcting it. Now here's what some of you already caught. We need to multiply 4 times this. But when we did it over here, I only multiplied 4 times x. I did not multiply 4 times -2. So really what we needed here is parentheses. Alright? Now what? Hold still. Hold still. Hold still. There we go. Now if I do this, I just have to change this. Instead of having -2, it's 4 times -2, which is -8. So I don't need to erase everything. I just need to change that 2 to an 8, which means I add 8 to both sides. Right? Which means 12 plus 8, instead of 12 plus 2, is now 20. And 20 divided by 4 is now 5. So you see, I didn't erase everything and start all over. The whole structure of the problem is identical. And now when you go and check it, and you plug in 5 minus 2, and divide it by 6, 5 minus 2 is 3. 3 divided by 6 is 0.5. Now it checks out. Same thing on both sides. I know this is the right answer. So now I know that's the right answer. I'm not guessing, hoping, maybe you'll be right. It's for sure the right answer. So if you want to do yourself a favor, go through the rest of these and put parentheses on all these. Okay, put parentheses on all those so you don't forget about that. All right.
I won't forget.
Okay, finish this up and please bring it back tomorrow finished, beginning of class. Of course, come into class checking every answer to make sure it's right. If you don't, do a check in the calculator yourself. Okay? All right. And you got about 12 minutes, so you could probably get a lot of this, if not all of it done, if you just work the whole time. Okay. Good luck.